Okay, so AI adoption seems to be moving faster than infrastructure can keep up. Just any thoughts you might have in terms of the gap between capacity and the folks trying to, leverage AI? What are you seeing in terms of that disjoint?
Yeah, I think this is something that a lot of people that are outside of the infrastructure space don't understand, but it takes a long time to get physical infrastructure built, especially large projects that require utilities, require community input, things like that. So where the CTO of a Fortune 500 company can make a decision in a day that they want to, quintuple their spending on AI, it takes years to go and get more data centers built. And the bigger the data center, the longer it takes. On top of that, the data centers that exist in this country right now are not optimized for AI. It's a totally different facility in a lot of ways because the density levels are orders of magnitude larger than what the existing data footprint is in this country. So you really need to go out and build new data centers. And to the extent you're retrofitting old data centers, you have some leg up because it's already permitted to be a data center. They have access to some power, but you need to completely gut and retrofit a lot of the components, especially for cooling, power distribution, the footprint of the rack space, the weight of the racks. It's all quite different. So I think what we're seeing now is that demand for data center rack space has exploded. It's outstripping the supply of chips, obviously. That's why margins are so great for people like NVIDIA. But NVIDIA is actually able to ramp up their production of chips pretty quickly as well. And Dell and HPE and Supermicro can ramp up their production of servers. What's harder to ramp up is energized rack space at the density levels that we need. And that's why you see these announcements about gigawatts and gigawatts of data centers being built. But the timeline under which they're going to be built, I think, is probably underestimated. It's going to take some time. So there's going to be a material demand overhang for high density rack space over the next few years. And that's what Greenlight is out here trying to fill.
Okay, and in terms of the actual measurable cost in terms of potential delays in data center deployment, do you have any I don't know examples or just thoughts as to things that are impacted and in terms of the actual business costs, how um, problematic could it be for folks if they can't access data center space in a timely fashion, I suppose.
Yeah, I think it depends on the company, where with some companies it's absolutely existential, and with some companies it is a competitive edge that matters. But if you think about the companies for whom it's existential, you have the hyperscalers that are in a race to go and build the most powerful core AI models. I think they all believe that they're going to achieve something that they would consider to be general intelligence at some point, and they view it as obviously better if they can achieve that sooner or have it be smarter than their competitors. So I think the hyperscalers are very much focused on trying to win the AI race, and they may believe that it could be an existential threat for their business if they ultimately lose, especially given the amount of money that they're spending and the risk they're taking. If you're an AI startup, it's even riskier because you've staked your whole business model on the ability to go and run AI computing. And if you believe you have access to rack space, you have access to chips, and then you raise capital and it turns out you actually can't get it for another 18 months, I mean, you're going to run out of money before you can actually go and build the systems that you've pitched your investors that you're going to build. So it could ultimately just kill the business before it begins. And then if you're an enterprise or a Fortune 500 company, it's a risk. I think that if you have two companies that are very closely competing against each other, and one of them builds out a successful AI strategy using all their proprietary data, and the other one is 3 years late in doing that, I do think the first one's going to have a material advantage, but both businesses may survive. So in any case, it's a very, very valuable problem to be solving right now.
Yeah, and I guess it's as I think you alluded to in the first question, the traditional data center planning cycles are sort of nowhere near as fast as the pace of AI innovation. Um, in terms of how that might impact AI-driven companies, just thoughts as to what you're seeing in terms of, again, whether it's theoretical or actual examples where people are sort of hanging around waiting for space. I don't know if that is the case or not, but
Yeah, it's interesting. It actually just started happening last week where the CEO of Microsoft said in an earnings call, I believe it was an earnings call, that they believe they may have GPUs that are sitting around in inventory unable to be deployed because they don't have enough access to high density rack space. That's a real problem, not just because you can't build your AI systems as fast as you'd like, but these GPUs are really expensive and they depreciate very quickly. So if you imagine that you're going to be swapping out your GPUs for every maybe 3 or 4 years, and you have them sitting in a box for the first 6 to 12 months of their existence, that's already a ton of value that has been destroyed. And I think that you'll see more and more entities out there that have that problem. I just got an email this morning from somebody saying that they're looking for 15 to 20 megawatts of high density energized rack space for NVIDIA GPUs, a neocloud company that needs it immediately. And what immediately means is they already have the GPUs, they've got no place to put them. The problem is co-location vacancy, according to JLL, is at I think 2.4% right now, down from 10% a couple of years ago. And the vast majority of space that's due to be delivered in the rest of 2025 and into 2026 is already pre-leased. So anybody who needs space immediately better be building their own data center and very far along in doing so, or they're probably going to have to wait in line. And I think that it's going to be a very, very difficult time for entities that are going out and buying GPUs without having 100% certainty on where they're going to place them and when that's going to be available. And I think that a lot of delays come unexpectedly for data center developers, where suddenly you get a different person gets elected, and you have more administrative hurdles to jump through. Maybe the power that you thought was available, the utility says, well, sorry, it's going to actually be another 18 months. And there's not really much you can do about that when that happens. So I think that the combination of people overextending themselves and buying chips when you also have data centers getting delayed is going to be a problem.
Okay, so bearing that in mind, is it easy for organizations to sort of evaluate whether their current infrastructure strategy is sort of fit for purpose in this? I mean, for example, does it make sense for people to buy GPUs and have them sat there? Um, or do they need to do that because GPUs might, there might be a rush on GPUs and then a shortage of supply. Just how easy, I suppose, is it for people to understand if their strategy is the right one in this
Yeah,
sense?
I think it's very hard to know. I think it's hard to know because the developers themselves sometimes don't have 100% certainty on when their project is going to be delivered, and they're subject to the same hurdles that come out of nowhere that everybody else is. So I think if you're an operator or if you're a company that is looking to run AI computing, it's best to have several options in play at any given time and probably run them in parallel. And that's expensive, but I do think that that's what the hyperscalers are doing. And I think it's also good to have some degree of control over the data center that's being built. So if you look at the transactions that have been happening with Google and FluidStack and Cipher, who are out there building data centers in more remote locations. Google did an interesting financial transaction where they're backstopping the investment going into the data center. And most likely they have the ability to step in if hurdles are not being cleared, where maybe they can control that data center development at some point in time. I don't know that to be the case, but that would be my assumption. But I do think that a tighter relationship between the end users and the data center developers is something that's probably going to be really helpful for the end users.
Okay, and then in terms of just sort of technology-wise bottlenecks, we've mentioned about acquiring GPUs. Are there other things? I mean, like traditionally, I guess the power side of things is often one that people look at. But just any thoughts you have as to some of those other bottlenecks apart from acquiring more compute power?
Yeah, look, I think NVIDIA would be pleased if they could produce double the GPUs that they actually can. Their margins are so high, and it seems like there's almost an endless demand for their equipment that there is some bottleneck there, and chip fabrication facilities are probably running at as high capacity as they can run. They're building new ones in this country, they're building new ones overseas. It doesn't seem like that's the greatest bottleneck right now, but it may be in the future after a lot more data center rack space gets energized. It also obviously could be a real bottleneck if a geopolitical situation makes it the case that you can't import chips the same way that you otherwise could. But based on some research we've seen, it appears that NVIDIA will ship as many as 8.5 million chips in 2026, and that would equate to 13 gigawatts of new data center capacity. So it seems like they've got the ability to produce a lot of chips. Then on top of that, you have each hyperscaler is producing their own chips. You've got AMD getting into the game in a big way. They've signed a contract with OpenAI now. You have OpenAI looking to potentially develop their own chips. You have a lot of new people getting into the chip manufacturing game. So our view is that it's probably going to be quite some time before the real bottleneck is chip production instead of energized rack space.
Okay, and is there any thought that all those folks you've described are kind of chasing the same business? Therefore, when people win certain business, then the market sort of shrinks, or do they all think there's sort of almost limitless demand for what it is they're going to be supplying?
It's a great question. Look, I think that's the multi-trillion dollar question that everybody would like to know the answer to is what is the ultimate market for AI? How big is that market going to be? How many companies are going to be involved in using it? And is it all going to be concentrated in the hands of the couple hyperscalers that win out? Or is it going to be more dispersed where you see a lot of enterprises with their own environments where they're doing their own AI computing and keeping their computing out of the cloud because they don't trust security or something like that? And you see maybe neo clouds that are renting out GPUs by the hour, by the week, by the month to companies like that. And then you see all the hyperscalers having their own systems that are all kind of succeeding in tandem. And the market's big enough to support all that. I don't think anybody really knows. I do think that that's a risk that certainly you're taking if you're investing in the technology companies themselves. By investing in the data centers, we think in a lot of ways you're investing in the picks and shovels where it's something that somebody's going to need. And even with AI technology where it is right now, assuming that the LLMs don't get any better than they currently are, and AI capabilities don't get any better than they currently are, we think that just implementing that technology over the next 5 years and creating businesses around technology that already exists but hasn't really been taken advantage of yet, that's already plenty of value to support all the data center investing going on at the moment. So we think that it's going to be potentially riskier to invest in the tech companies. They've got more upside as well. If they win the race, that's great. But if you're investing in the underlying infrastructure that's going to support AI computing, somebody's going to need to use that.
Okay, and so let's come on to Greenlight Data Centers yourselves, and you focus on power first development, I think is the phrase. So, how
Yeah.
does prioritizing power availability and stability, I guess importantly, impacts overall performance and uptime when it comes to these, we're talking about these AI workloads, I guess.
Yeah, so the traditional way to develop data centers has been to find out where data center occupiers want to be from a node standpoint, from a latency standpoint, from the standpoint of being on top of fiber lines, and buying land in those places, and then doing whatever you can to try to get power delivered to that land as quickly and as cheaply as possible. So that's the traditional playbook. That's worked very well for a long time. And that method of developing data centers is more valuable than ever right now. If you have land in Ashburn, Virginia, or in Elk Grove Village in Chicago, or in Santa Clara, that land is more valuable than it's ever been right now for data center development. Problem is, there's not enough of it, and there's not nearly enough power already in those places or near term in those places to build enough data centers to support the AI boom. So what we're doing is we're saying, let's find out where there is extra power, and not just extra power in 3, 4, 5 years, but there's actually capacity to go and serve firm load right now. And that's a lot of the country that has overbuilt renewables. What people may not know is that you have renewable power generation, solar and wind, that is often curtailed, meaning that they just freeze the turbine blades or they run the solar power into the ground because there's not enough demand in that particular location and there's not enough transmission to bring that power into the big load centers, into the big cities. So there's a bunch of wasted power that exists. There's power that gets sold at negative power prices because people get the production tax credit when they're producing wind power, and they would be willing to sell that power for negative $15 a megawatt hour, overload the grid, and receive the production tax credit that's worth $27 a megawatt hour. So there are parts of this country where there's actually way too much power, but that's not where everybody's wanted to build data centers in the past. It's mostly in the Midwest, it's in Texas, it's in some parts of the South, but that's where we're going, and we're talking to the utilities, we're talking to the co-ops, we've been doing this for years, and we're trying to find locations within their system where they point to a substation and they say, look, if somebody built a data center right there, we can go serve them power tomorrow. And we'd be able to size up that data center to a larger data center within 12 months or 18 months with some substation upgrades. But you don't need to do transmission upgrades. You don't need to build new generation. We would love to have somebody go and build something right there. And we say, okay, well, we'll evaluate it. Is there fiber nearby? Does it have all the other ingredients that you need in order to build a data center? Sometimes no, but a lot of times the answer is yes. And then we go and buy that land and develop a data center that can be energized much, much more quickly than you get the main data center hubs.
Okay, and I guess in this day and age, things like extreme weather and grid instability are becoming more common.
Mhm.
Is it possible to design facilities to withstand these risks, or at least mitigate them as far as you can, but also maintain efficiency and uptime? Because obviously uptime is, I guess, the number one requirement for a data center. Nobody wants to be sat there with a data center that's not doing what it's supposed to do. Yeah.
That's right. That's right. And we're 100% focused on maximizing uptime as well. It is not the case that we're saying, oh, we'll build data centers that are cheaply built and they might be down a few percent of the year. No, we want to find sites where we can energize a data center that is, tier three uptime, which is over 99.9% of the time it's available. And to your question around extreme weather events, I think it depends on the event that you're talking about. Nobody's going to build something in a floodplain. That doesn't work. Hurricanes are a risk that people see in many cases as too great. So in locations where you're near the Gulf Coast and a lot of Florida, that's not going to be a target market for most people building data centers. There are data centers that exist in those places because in some cases you need to have some amount of computing close to population centers. But if you're building a big AI data center, chances are you probably avoid the Gulf Coast and Florida and places that are liable to get hit with hurricanes. When you talk about tornadoes, it's a little bit different because they are a bit more random in where they hit and they hit throughout very big chunks of the country. I think that it can be a little bit expensive to retrofit for potential tornadoes. You're probably not running a lot of overhead lines and things like that. You're going to have to bury your lines. But people are very much building data centers in Tornado Alley. So you see Oklahoma, North Texas, the Panhandle of Texas, Nebraska, Iowa. These are all becoming very, very intense data center states, and that's where you see the most tornadoes as well. So that's just something where you have to know what the risks are. We've got a whole list of all the potential natural disaster risks and kind of a scale of 1 to 5 how risky it is. And then you just make sure the data center is built to withstand that potential risk.
Okay, and then other sort of considerations, I guess, around things like early utility partnerships and local stakeholder engagement. So, um, how important are both those in terms of helping to shorten build times and I guess therefore de-risk sort of AI infrastructure projects as far as is possible?
Yeah, they're both critically important. I wouldn't say that it's kind of either or, it's really both. You need to have a utility that is happy to serve you the amount of power that you need. You need to have a community that is mostly happy for you to come in. I think there's always going to be at least one or two people that don't want to see any development at all, but I think the benefits data centers bring are obvious to a lot of people, and some communities are more receptive than others. You need both. Early utility engagement for us is critical. I'm not sure that everybody necessarily sees it that way. I think a lot of people say, hey, I've got this real estate. Let's just see how long it's going to take for me to get power. Let's see how much money it costs for me to get power served here. Our business is built around early utility engagement. So we have NDAs with literally hundreds of utilities and co-ops, and we're talking to a lot of people in the power industry all the time about where we can get energized and when. So that's something that the business is built around. From a community engagement standpoint, part of it is building something that the community isn't going to hate. Part of it is making it clear to the community exactly what it is you're doing, because people ask, oh, there's going to be so many data centers built in Wisconsin that it's going to drain the Great Lakes. Well, that's not true. In fact, a lot of data centers don't actually need very much water. And I think communicating that reality to the community is very, very important, and doing it in a way that respects their concerns and hears them out, but also explains what it is we're actually trying to build is super important. So being there, being in the community, letting people know what it is you're doing, and having people in the community like the economic development groups and the mayor or the county judge helping to tell that story, that's something that's super important because it does ultimately bring a lot of economic activity to areas that sometimes haven't had a lot of economic activity for a long time.
And in terms of what's gone before, if you like, are there any particular lessons that yourselves have learned or other data center operators could learn from I'm thinking particularly the hyperscalers. There've been maybe some failures or sort of projects that have underwhelmed. So are there things that people can learn when it comes to designing these, whether you call them gigawatt factories or AI
Right,
ready
right.
facilities? I mean, there's different sizes, I guess, isn't there? But yeah.
Yeah. Yeah, look, to be clear, one thing that we've learned is smaller data centers are more palatable to a lot of communities, and they're also a lot more interesting for the utilities and co-ops because you're not looking to do a wholesale change of their system. You're not looking to build some single facility that might take up 20% or 30% of their total power capacity of their system. So we focus on sub 100 megawatt data centers. We want to build data centers that are right sized for the locations they're going into and the right size for the infrastructure that already exists. And I think that's a better story to tell for the community too, because they're going to get the benefits of a lot of jobs coming in. They're going to get the benefits of a facility that might cost hundreds of millions of dollars to build coming into their community, but they're not going to have to see some data center that's going to span many, many acres and is going to completely change the character of the area. And I think you see a lot of these hyperscaler facilities that are getting built, they get a lot more pushback because of the sheer size of what it is they're doing. So we definitely try to make sure people understand that we're building data centers that are right sized for the communities that they're in, and they're not these gigawatt plus facilities. I think other than that, it's a lot of the things that there are risks out there. You know that potentially land could be contaminated. You've got to do the work to figure that out. You could have potentially endangered species or wetlands or things like that that you've got to just spend the necessary time to go and find out whether or not that's the case, and that could kill projects early. We've had that happen. Everybody's had that happen. So you just have to be awake to the risks that you are taking when you go and start developing a data center site, and know that some of them are going to fall away for those kinds of reasons.
And I'm just wondering, I mean, if it's a silly question, apologies, but obviously folks talk about these gigawatt factories, but is it in fact perhaps potentially more sensible to build, say, 10, 100 megawatt data centers and sort of cluster them? And if they're in
Mhm.
different locations as well, when the inferencing part of AI comes along, they're,
Yeah.
well positioned because obviously the hyperscale potentially can be built in, remoter locations because, latency and things like that aren't necessarily an issue. Just your thoughts, I suppose, as to whether that might be a trend over time.
Yeah, I think there's a bit of a bifurcation where I do think that there are going to be software programs that exist in the coming 10 years where it's a real benefit to have a gigawatt or more in a single location with all of the computing packed together as closely as possible. If you're trying to train a frontier large language model or you're trying to create the next level of intelligence, that's something that you would like to have. And I think that all of the hyperscalers are doing that. They all have facilities of that size in the pipeline, and there are other people that are trying to build facilities that size that are ultimately going to be used by the hyperscalers. But that, I think, is a relatively limited part of the overall computing market that's going to exist. And I think it's easy to forget that 100 megawatts or 50 megawatts or 20 megawatts of computing with cutting edge GPUs is a tremendous amount of compute power. I mean, ChatGPT-4 was trained on GPUs that are now considered functionally obsolete, and it used less than 50 megawatts of computing. And ChatGPT-4 is pretty powerful. If you use those same 50 or less than 50 megawatts of computing with Blackwell, GB300s, you would have a much, much more powerful model. And then if you use a gigawatt with GB300s, it's going to be even much more powerful than that. But the truth is, a lot of enterprises and a lot of AI functionality and a lot of AI models that are not built on the entirety of human knowledge, but maybe are built on a more limited context window, like think millions, but not billions or trillions of data points, you can do a lot with 5 megawatts of computing. And we think that a lot of enterprises that have their own proprietary data that they want to go and train a model on are going to want to use smaller amounts of computing. They might be location tenants, they might be running their own environments, but it's going to be a smaller footprint. So we think that there will be a space for that actually being a better way to compute. It's also a way to deploy a lot of computing much, much faster because we can go and build a 50 megawatt data center way faster than somebody can go build a gigawatt data center. And again, I think there's a massive overhang of demand that's going to exist in 26, 27, and 28. And I think the smaller data centers are well positioned to meet that demand.
Okay, and in terms of the future, which, as we discussed, is maybe not completely certain in terms of what's going to happen, but how possible is it for companies to future-proof their AI infrastructure, and even yourselves when you're building, yeah, how flexible, scalable, all those sort of words. Um, is it is it achievable to sort of plan for 5 to 10 years, or bearing in mind we probably don't even know what's going to happen
Mhm.
in 5 or 10 years' time? Is it a slightly pointless exercise to second
Yeah.
guess it? Just your thoughts, I suppose, as to how folks do or don't consider the future.
Yeah, I think the level of uncertainty in what data centers are going to look like in the future is higher today than it's ever been. I was at the NVIDIA GTC conference in March out in the Bay Area, and Jensen Huang was up there on the stage talking about how the next iteration of GPUs might take up as much as 600 kilowatts a rack. And beyond that, who knows, maybe it's over a megawatt per rack. To put that in context, data centers traditionally have taken up less than 10 or 15 kilowatts per rack. So you're talking about potentially a 100x increase in the amount of density that you have and just delivering that much power, off taking that much heat. It's a totally different building that you're talking about building. And today the GB300s can do well over 100 kilowatts a rack. So you're already at that density level that's way higher than you've seen in the past. I think that the key when you're building a data center now is having as many components as possible be compartmentalized where they can be swapped out in the future. And you can keep as much of it as possible fungible, where that's going to be useful whether you're doing, 100 kilowatts a rack or 1,000 kilowatts a rack. So if you think about the transformers, the switch gear, the shell, all of that stuff, I think can be the same. You want to make sure that your geotechnical and your floors are capable of taking much heavier stuff in the future. But your cooling, your power distribution, that might all need to get swapped out when you swap out your next set of servers that come in. And I think it's just being careful to have your building be designed in a way where swapping out all the power distribution and all the cooling doesn't mean that you actually are effectively rebuilding the building, that you can go and maybe cordon off half of the white space that you just are no longer using anymore because the power is put into a more dense area, and you're able to just kind of run those cords over to the new area where it's in the corner of the data center, and you can keep using the old data center for a very long time as you're using less and less space with that data center.
Okay, and maybe finally, and you've sort of semi-answered it there, I guess, by explaining the sort of future-proofing things to look at. In terms of folks who are planning AI initiatives, are there any particular sort of key questions or things they need to look out for when they're asking about infrastructure readiness, so they can avoid those bottlenecks? Well, I guess both, sort of as quickly as possible, but then also into that sort of future scenario.
It depends, I think, on what your relationship is going to look like with the data center operator. I think in the hyperscalers cases, they're running their own data centers a lot of the time. In the case of neoclouds, they're signing long-term leases that commit them to a given facility, and they're going to have a ton of input on exactly how that facility is built out, so they're going to be able to largely control it. If you're talking about colo space, that can be a much shorter lease. And so it's really the colo operator that needs to decide if they're future-proofing their data center in a way that works for everybody. But I think the longer the lease and the greater commitment that the tenant is making to the facility, the more they need to have their hands in how the facility is designed or what the facility is going to look like, assuming that you have to double or triple or quintuple your density at some point in the future.
Okay, and maybe just finally, I know we've sort of touched on it already. Do you foresee that there will be at least in the short term, a real problem mismatch between capacity and power and AI demand, as it were, and there will therefore be quite a significant disruption, or do you think that for some of the reasons we've discussed, particularly about the anticipated size of the market, etc., things will sort themselves out, or you see some disruption ahead?
Yeah. Yeah, I think there'll be disruption. I think that the disruption, it's not necessarily between the total amount of electrons generated and the total amount of electrons that need to be used. Data centers don't run 24/7, 100% of the time. Their usage is up and down. Um, Power, there's plenty of power being delivered in this country. It's just a lot of the times it's being delivered when it's windy and everybody's at wind, or it's very sunny and everybody's producing solar power. It's matching up the times that the power is being produced and delivered. It's actually having the transmission infrastructure to deliver it to where the data centers are, and it's matching the data center use to when there's power available. So there could be a tremendous amount of value that would be created if data centers were able to curtail or able to shift their load from maybe a data center in Texas to a data center in Oregon or something like that based on where there happens to be available power at that given time. I think there is software that's in the works right now that helps enable that. But I think that this, in the utility space, they call it capacity. This shortage of capacity, where you have just 24/7 capability of being able to run to your maximum load, that is something that we're already seeing. In a market called PJM, it's a market in the northeastern United States where you can buy and sell power and buy and sell capacity. Capacity prices have spiked to large multiples of what they've traditionally traded for because people are effectively hoarding this ability to buy capacity because they know that having access to delivered power 24/7 is something that's going to be very, very scarce. That's already happening now. It's only going to be more and more scarce as some of these gigawatt plus facilities get energized over the next few years. And I think that people need to very much focus on transmission, on energy storage, and the progression of batteries as a viable way to put power into the grid when there's otherwise not power being produced. And even someday, demand response from data centers where they're able to shift their load from one place to another during those peak times to solve that problem. Because absent that, it's already a problem now and it's only getting worse.
Yeah, it's been great to chat, and thank you so much for sharing so many great insights into what is obviously a complicated and fast-moving picture at the moment. But Alex, really appreciate your time. Thank you so much.
Yeah. Thank you very much. It's been a pleasure.